Hello and welcome. In today's video we will discuss how we can design a minimal automated irrigation system. So let's start. First of all, we need to address what is our main water source. So we know that the irrigation system is meant to water some plants or used in agriculture. So in my case, I have two main water sources. First one, it's the water from the roof, which will be stored in the water tank. And the second water source, which will be used when there is no rain outside, it is a fountain. This fountain should be at the location where the automated irrigation system is implemented. So this water source, it's a fountain with a mounted hydrophore. So this hydrophore, when will be emptied, it will automatically start and store a couple of liters of water into it. So we can control it and fill up the tank. Good. So basically we identified what are our water sources. This control of the hydrophore will be done with a microcontroller, which will control a solenoid valve and will turn on or off based on some logic implemented inside the silicon. Good. So the next step would be to see what we need as a sensor set for our system. First of all, we need to read from the water tank for the whatever logic we will implement inside the microcontroller, or whatever are the requirements, we need at least a water level. Also, besides the water level of the tank, we will need also the water temperature. We know that it is better for some plants to water them with a water temperature which is suitable for irrigation. Yes, for example, you cannot water the plants in the mid-sun with the cold water. So it's better to have the possibility to track also the temperature of the water. Yes, and maybe postpone the schedule to water in the during the evening or in the morning. Good. Moving on from actuator part, how we will drive the second solenoid valve to start the watering itself will be done also by the microcontroller with a second solenoid valve and turn on and off. Then of course this is the most simpler solution, but should be sufficient in our case. Moving on, besides the sensors which are addressed for the water tank, we will also need to monitor something from the soil and from the air. Basically, we will start with a humidity sensor from the soil, because usually for each plant we will need a certain humidity to thrive. So for sure we need to track the humidity from the soil. Also in the logic that I said in the earlier regarding the outside temperature, we need to make sure that humidity and external temperature from the air is also tracked. and include this together with the water temperature in the main logic for the microcontroller in order to create the best and optimal environment for the plants. So the requirements for this logic will be addressed later, but we want to basically track the earth, air, and water sensor sets that could be more or less, but usually we address 3 types of sensors from the earth, from the air, and from the water itself. Good. Now from monitoring and controlling the system, we will use 2 options. One is the remote. One solution would be to use a SIM module, a GSM module basically, where we send via 80 commands, yes, and these 80 commands will be implemented in the microcontroller and correspond with the GSM module, and the GSM module will give us the information that we request via a mobile. This will be addressed in particularly and in details later on, but this will be to control the system from a distance without the need to be at the location. Then of course it could be also controlled via a wire locally. A PC if should be connected to the communication protocol, basically WART, a serial one, which could be also done locally, but this would be optional. Okay, so this should be enough as a starting point to have implemented. Of course, even if it seems to be small and let's say simple at the beginning, addressing each connection and each reading and driving the correct actuators, it will take an effort to implement this system, and for sure it may be change a little bit during the development phase. Of course, an important aspect which I did not mention is the overflow valve, which will be a mechanical one, which doesn't imply any logic, only that should be added an overflow valve in if the roof water will get too much and will fill up the tank. This water will be drained out from a water valve. Okay, so basically this is all. What kind of sensors and actuators and microcontroller class will be used, this will be chosen later, but basically this is only the system overview and should be enough as starting point. Thank you very much, and if you have questions or ideas, just let me know. Bye.